A world of gadgets surrounds us, whether it's this, or this, or this. There's one thing we don't want to hear.
Sorry, I'm having trouble with the connection. Please try again in a moment.
And for this, we need this.
Wi-Fi is a technology for wireless local area networking or WLAN. Devices that use Wi-Fi technology include laptops, smartphones, digital cameras, tablets, and many more. Wi-Fi compatible devices connect to the internet via a wireless access point, also known as a hotspot. Such an access point has a range of about 20 meters. Wi-Fi uses the 2.4 GHz ultra high frequency and 5 GHz super high frequency radio band. Radio waves are a kind of electromagnetic radiation. Electromagnetic radiation comprises of perpendicular electric and magnetic fields propagating through space. Electromagnetic waves are produced by accelerating charged objects. Electromagnetic radiation has many frequencies within it, each of which has numerous applications in many appliances. Radio waves is just a certain band of frequencies present in the spectrum.
A router is a networking device that forwards data packets between computer networks. A wireless router is a device that performs the functions of a router and also includes the functions of a wireless access point. When a certain bit of data is passed into the router, say through an Ethernet cable, the router converts this into radio waves through a certain form of modulation called orthogonal frequency division multiplexing or OFDM. Now, if we have a router and a bunch of devices connected to it, how does the router know which device the data should be sent to? For this, we have something called the MAC address or the Media Access Control address. The packets of data sent by the router are tagged with the physical address of the receiving device and it is broadcasted. That is, it is not sent to a particular device, instead, it is just sent to the atmosphere with the MAC ID of the receiver. All the devices in the range of the access point captures this packet, but only the one with the MAC ID specified in the packet will process it and retrieve the data, and then an acknowledgement message is sent to the sender indicating the successful reception of the packet, and the next packet is sent, and this process continues. This is why when multiple devices are connected to the same router, the internet access slows down. The main component of the Wi-Fi router is the antenna. The antenna is composed of a copper wire which is in a physical enclosing which ensures maximum amplification. When the Wi-Fi router receives data from, say, a cable, it converts this into an alternating current, which forms the electrical signal with a desired frequency. When this signal excites the copper inside the antenna, the free electrons in the copper wire get excited and start accelerating to and fro. This causes the generation of electromagnetic radiation in the form of radio waves.
A service set identifier is the unique ID of a Wi-Fi access point if there are many such access points present in a region. But even this does not guarantee network security. So, Wi-Fi has adopted various encryption technologies. The earlier encryption technology, wired equivalent privacy, proved easy to break. So, higher quality protocols such as Wi-Fi protected access (WPA) and WPA2 were added later. We will now demonstrate an experiment to determine the relation between distance and transmitted signal strength of a router. The free space path loss is the loss in signal strength of an electromagnetic wave that would result from a line of sight path through free space with no obstacles nearby to cause reflection or diffraction. This free space path loss is given by the above formula. What we did in the experiment was we set up a Wi-Fi router and we basically kept a track of the Wi-Fi signal strength as a function of distance from the router. Now what we aim to do is to establish a correlation between empirical data we found and the data using this formula.
The values that we obtain may not match perfectly with the equation. The experiment was conducted in an open corridor but was not conducted in an open field, so this may affect the values. Also, the app refreshed only once every second. This may have caused errors in the readings.
The variation was supposed to be linear with distance from router according to free space path loss equation, but that is not the case. Also, you will notice a sudden variation at around 15 meters from the router which is probably due to the fact that the readings after that were taken at a different altitude.
We hope this was informative. Thank you very much.